Hello guys, so we are back with the beta not hat estimate. As we have told you that I will discuss the aspect of the expected value of beta not hat, okay? The bias, because what is a bias? An estimator is called the bias on estimated t. Suppose we're estimating theta with t. So therefore, what we are trying to do is our theta hat say, okay, that makes much more sense. Oops, what happened just? Oh, nice. It gets deleted anyways. Theta hat. So if you do theta hat in that sense, then we tell the bias of theta hat is actually equal to expected value of theta hat minus theta. Sort of the distance between the expected average value of theta hat minus the actual parameter. So that's the bias. Okay. So we are sort of seeing how the average value of the estimator is more from the actual value of the estimator. Okay. So we'll see in the last video by some examples why this average value and why this, what is the exact beta not had and beta not is coming up. Okay, let's see this video at the end in our example, a similar example. Okay, so let's do it now. So let's calculate the expectation of beta not had. So what we know beta not had? Beta not had is what? Beta not had is equal to y bar minus beta 1 hat x bar. So this should, so therefore, expectation of beta naught hat is equal to y bar minus expectation of beta 1 hat the x bar. So that, therefore, it implies that sort of it's useful to calculate expectation of beta 1 hat first and then go to expectation of beta naught hat. Therefore, this video is actually dedicated to expectation of beta 1 hat. So what was beta 1 hat? Do you remember? Beta 1 hat is actually summation of xi minus x bar into yi minus y bar by sxx. That is actually I wrote sxy by sxx. Now let's do some calculation stuff, very basic calculation stuff. Summation of xi minus x, we can write the summation of xi minus x by yi plus summation of y bar into xi minus x bar, right, by sxx. So now observe this is equal to 0. Why? Because summation of xi minus x bar equal to 0. This is very easy. So therefore it turns out that it's summation of xi minus x bar by into yi by sxx. Now the very beautiful thing is that this x and sxx are constant. So you take expectation, guys. So what you get? Expectation of summation of xi minus x bar by sxx into yi is actually equal to, by linearity of some expectation, we get summation of xi minus x bar by sxx into expectation of yi. Now yi follows what? Yi follows something. So yi is what? Remember what? Yi is actually beta naught plus beta 1 xi plus epsilon I. So expectation of yi is beta naught plus beta 1 xi. So just replace it here. So we get summation of xi minus x bar by sxx into beta naught plus beta 1 xi. Okay. So let's try to understand it much more carefully. Summation of xi minus x bar by sxx into beta naught plus summation of xi minus x bar by sxx into beta 1 xi. Perfect. So what do we get now? We get that, observe this is constant, like these things are constant, right guys? This thing is really constant over here and therefore this goes to 0. It's sort of constant into summation of xi minus x bar. So it's 0, right? What about this? Observe this very carefully. So we get this beta 1 out here outside and we get summation of xi minus x bar times xi by sxx. Observe that sxx can be written as summation of what? Xi minus x bar times xi minus x bar, right? So it's written like this, right? Observe that this term is 0. So therefore, the superbola part this upper part is actually equal to this lower part. So it cancels out. So it's actually equal to beta 1. So what do we get? Expectation of beta 1 hat is equal to beta 1. So the bias of beta 1 hat is equal to 0. So that's the basic idea. Okay. So this is the idea of the expectation of bias of beta 1 hat. Now what we will do is we will calculate the bias of beta naught hat in the next video. Okay, this is the essential idea. So let's get back to you in the next video of bias of beta naught. Bye bye. See you. Stay tuned. Stay blessed.